Right, we need to look at wind generators, otherwise known as wind turbines. They are not windmills. Windmills are used to make flour. So this is a windmill. We're not talking about these. Now, how do they work? They have large blades that spin round because they're basically pushed by the wind. The kinetic energy of the wind pushes the turbine, and so it gets converted into kinetic energy of the turbine. Then the turbine is connected to the generator, and the kinetic energy of the turbine is converted into the electrical energy produced by the generator. So we produce electricity. So kinetic energy to kinetic energy, and then kinetic energy in the turbine to the electrical energy in the generator. Next, some people, however, do consider these to be a problem because they say they're noisy, they get noise pollution, and they're an eyesore, which means they basically ruin the view of the landscape. Also, there's some concern that they harm the wildlife, in particular migrating birds and bats. This is a wind turbine in a farm of 19 wind turbines in a farm whose name I can't possibly pronounce, but it's near Aberystwyth, which is in Wales. Each farm produces about 10 megawatts. This is another wind turbine which is out at sea. These are much larger. Each turbine produces nearly 4 megawatts. Out at sea, you have higher wind speeds because there's no trees and there are no buildings. There was also nobody to complain about the sound pollution. However, they're not so easy to maintain. We need to be able to work out what is the power produced by a turbine. Let's consider in 1 second we have a volume of air which is passing by the wind turbine. This air has a volume which is basically the area times by the height, A times x. Now x is basically, in that 1 second, is the velocity times time, which is basically the velocity in that second. So if it travels at 4 meters a second, that length will be 4 meters because of that second. So the volume of air is basically AX, or A times by V delta T. We want to find the mass, so we rearrange the mass density equation. So the mass is equal to density times by volume. And then once we have that, we can work out the energy of the air, which is the kinetic energy, half mv squared. Substitute that in, and we have two terms for v. We have v and v squared, so it becomes v cubed. Now this is the kinetic energy in 1 second. We basically divide by t, we find the kinetic energy produced per second. In other words, the power is half rho a v cubed. We can work out the a, the area, from the radius of the circle, which is the length of one of the blades. Now, if all this kinetic energy is converted into electricity, then this would be the power that's produced. Of course, this can't be the case, because it means that the energy of the wind would all be used up. In other words, the air would stop as soon as it gets past the turbine. But so in reality, it's between 35 and 45% efficient. How do we increase the power? Well, you can basically increase the area of the sphere of the cylinder or the velocity of the air. Now, the problems are that it's not 100% efficient. Some energy is lost as the friction of the moving parts inside the turbine, also due to the resistive heating of the wires. Not all the kinetic energy of the wind can be given to the turbine, as I just mentioned. And also, if you have many wind turbines, the energy is removed a little bit from the air, so there will be less energy available to the other turbines. So you can't have them too compactly placed. Also, when there are strong winds, there can be risk of damage to the turbine. Problems. Now, we've already said that wind turbines can be an eyesore. You see that these wind turbines have basically completely spoilt this landscape. So we have visual pollution, we have sound pollution, there is the harm to wildlife. They're not reliable because it depends on the weather, and they're not 100% efficient. These are two possible designs. This is a horizontal axis that we've already just discussed. This is a vertical axis which doesn't have to be pointed towards the wind because it works at all angles. This has to be orientated to be facing the wind. Also, when this moves very quickly, the shape of this changes, so it reduces the chance of damage. One article here that was in the BBC website was that there's a story that there were these bats that were found dead at the base of these wind turbines with blood coming from their mouths. Now, they weren't vampire bats, they just hadn't been into town to bite people. What had happened is that as they get near the blades, there's a rapid change in pressure as the blade goes past the bat. This is too much for the little lungs that these little bats have, so their lungs basically rupture and then they die. It's very sad, really.